for it. So.
No, absolutely. I got talking about everything else, and so I'm just opening the spreadsheets we'll be using to. So, but also Monday, next week we have another exam.
Uh-huh.
And I don't know if you guys, I mean, you probably can't come to the group meetings, or you would, but even if you can watch the video, I have asked him to go over examples of the exam questions, you know, because like he said in one video that these quizzes that we take and we do so good on them, and then we don't do as good on the exams because we really have to dig for the information, whereas with these quizzes, it's already, you know, it's kind of
given. Yeah.
And so he's going to help us, you know, dig that information out. So if you can watch it, that'd be great.
Yeah. Is that on Monday he's going to do that?
Yeah.
Okay,
yeah.
Sweet. I'll make sure I at least watch that one, even if I don't tune in for it still.
Perfect. All right. So I'll start this show. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply. It needs to be a simple random sample was drawn from each population. That is true, correct?
Yes.
X bar is normally distributed for each group. That is correct.
Yep.
And then mean mu is greater than 0. That is not correct.
I believe so.
The sample size must be the same for each group. That is not correct. So it's just the first two, correct?
Yep.
Yes.
All right.
So for number 4, the test statistic for hypothesis test comparing two means with independent samples is a t-score, right?
Perfect.
Two samples are independent if knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2.
Perfect. The second one, right?
Yep.
Okay.
Okay, dentist office stuff.
All right. For the next 6 question, use the data file dentist office bills. This data represents a simple random sample of dental bills at the dentist office in Idaho Falls and a dentist office in Rexburg. Let mean U1 be the mean bill at the Idaho Falls office, and the mean U2 be the mean bill at the Rexburg office. Perform hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, which means we have a null hypothesis. Mean U equals mean U2, mean U1 equals mean U2. And alternative hypothesis of mean U1 is less than mean U2. Use a level of significance of 0.1. Okay, so what did it say? Let Rexburg be mean U1. So Rexburg will be the first group, and then Idaho Falls will be the second. Am I right in assuming that?
Yes, that's what I did.
Yes.
Okay. Okay. Okay, so what is the degree of freedom? And I have 19.
That's what I have.
Hold on a sec. So this is, sorry, I'm just doing this real quick. $19. I'm going to, okay. So what all do we have to have filled out in order for it to do the degrees of freedom? Do we have to have like the mean, standard deviation, and number for both variables under the summary statistics filled in?
Oh, you know what? I just put this under paired sample t-test. I need a 2-sample t-test. Sorry. Go ahead with that question again.
Okay, so I was just wondering if for the summary statistics, we need to have the mean, standard deviation, and standard deviations in order for it to show us an accurate degrees of freedom, or if it is not involved in that. I don't think it is.
So.
It doesn't look like it is.
No, I think it's just asking for what it populates with.
Okay, then I have 37.996 for under the equal variance is not assumed 2-sample t-test.
Mm-hmm.
Is that what you have, Hannah?
Yeah.
Okay.
I do now. I had it in the wrong. I had it in the wrong.
Okay, I just want to make sure I was doing it the right way.
Yep. I was doing the paired sample test until instead of the 2-sample test. So it's 37.996. That's what I have. Sorry.
No, you're good. I just want to make sure we're all on the same page.
So 37.996. Nope. Thank you for catching that. Ooh.
Yeah.
Okay. So the sample standard deviation for Rexburg is
that the 206?
200. Say that again.
Sorry, is that the 206 number?
Yep, I have 260.059.
For the
Or no, the standard deviation. I think it's isn't Rexburg number 2?
Mm-hmm.
So wouldn't it be 208.875?
Okay, hold on. Let me just off this.
No.
So if Rexburg is number 2, I have 206.637.
That's what I have as well. Yeah, 208 number for the other one.
Yeah, 208.875 for Idaho Falls.
So did you put Idaho Falls in variable 1 or variable 2?
Variable 1.
Yeah.
Oh, that's why. So for me, Rexburg is variable 2. So, or 1.
Okay.
So it's 206.637, right?
Yep.
Yes. Question 8. What is the test statistic? It's a negative 0.434.
That is what I have.
Penny, is that good for you?
Alrighty.
Let me,
Did you get
sorry,
that
I'm
as well? You're good. Don't worry about it.
0.434, right?
Yep, negative 0.434.
Oh, see? Negative 0.434. That's why mine are backwards. I'm getting the backwards answers.
All right, and so for the p-value, I got it's 0.667.
That's what I have as well.
0.667, that's what I have. Okay, so what is the correct decision based on this evidence? And we were at 0.1, so we failed to reject the null. Because it was 0.1,
And the
right?
p-value is 0.66, right?
Yeah, oh, when it's low, reject the null. So we reject the null. No, we failed to reject it.
Yeah, we should fail to reject it because it's an alpha of 0.10.
Yep, and 0.6 is bigger than 0.10.
Yes.
That it
0.1,
is.
so, okay. Failed to reject the null, okay.
Suppose instead that you had used the alternative hypothesis.
Ooh, I did the wrong. I think we might have done the wrong alternative hypothesis.
What? Sorry?
Oh, I have not equal to, and it was supposed to
Less
be.
than.
Oh, same.
Yeah, so if we change it, it only changes the p-value. Everything else is the same.
To 0.333.
Yeah, to 0.333. Yeah, that's the p-value.
Okay, hang on just a second. I'm putting my data back where it needs to be. Okay, and you got, for the p-value on a greater than, you got 0.333?
On a less than.
Oh, on less than. That's right.
Yeah, because mean 1 is less than mean 2.
0.333. Okay, so we're at, okay, 0.333. Okay, I got that.
Awesome.
Okay, so then if we change it to not equal to, let's see.
It's what we had before.
Then it's the 0.667. So what is the question?
It's saying, suppose instead that we use the alternative hypothesis, mean 1 does not equal mean 2. What is the correct decision based on this evidence? So it would be that we have insufficient evidence that the mean dentist bills between the two cities are different.
Agreed.
And now we use the freshman dinner. Yay.
Okay, I'm gonna clear out my data.
So it'll be freshman students from Utah on the left, freshman students from Colorado on the right, just so we're all on the same page, if that works.
Okay. Who wants to do this one?
Just finishing putting in the data.
Oh, you bet.
Okay. You want me to do it?
Sure.
The next 6 questions use a data file, freshman dinner. This data represents the number of times freshman students from Utah and Colorado cook their own dinner in a month. Let mean 1 represent the mean number of times a month that a student from Colorado cooks dinner, and let mean 2 represent this mean for Utah students. You suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis mean 1 equals mean 2. Use a level of significance of 0.05. So we need to,
So it should be a greater than, I think, right? It would be our type of test, like what our alternative hypothesis would be, right?
yes.
Well, it does. Okay, I guess. What makes you, walk me through this? What makes you think it's greater than?
So for me, so obviously our null hypothesis is that they cook for themselves, dinner for themselves, the same number of times. But it says that you suspect that freshmen from Utah actually cook dinner for themselves a different number of times. So it would be not equal to then. Sorry, I thought it said greater. But so we suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. And so it should be our alternative hypothesis is not equal to, not greater, but not equal to.
Okay, that's what I thought.
Yeah, I misread it. So thank you for making
that's
me
okay.
talk that through.
Yep, that's okay. All right, so what is the appropriate alternative is not equal to U1 is not equal to U2. Perfect.
And so then for the 2 sample t test for means, we want to make sure that it's not equal to in the type of test, right?
Correct.
Yeah, the type of test would be not equal to.
Yeah.
Okay, and the test to 0.845, correct?
That's what I have. And then the p-value I have as 0.411.
Yep.
That's what I have.
What decision do you make? So p-value is
So we have an
0.05.
alpha of 0.05, yeah.
So it's bigger. So we fail to reject the null hypothesis.
Yep.
Yep.
That's what I would do.
Okay. Determine a 95% confidence interval for mean U1 minus mean U2 and estimate for the difference between mean U1 and mean U2. Input your answers below. Determine the margin of error. Okay, so we're going to go a 95. And are we still leaving it not equal to?
Yeah.
So I'm going to take the high minus the low divided by 2. Let me just put brackets around this. And I get 3.680 or 3.6.
0.1, is that what you said?
Yeah, 3.681 for the margin of error.
That is what I have.
Okay.
So lower would just be negative 2.214.
Yeah.
Yep.
Upper bound 5.147.
Got it?
Should be.
Oh, look.
Yeah, that one was a lot quicker. I liked that.
Same.
I do too. Okay, so save all. Go to submit.
Oh,
Hit
good
submit
job.
like 17 times.
We missed
Me too.
Missed
2.
2 points worth.
We missed, what is this test statistic? We put 0.845. And then the lower bound was negative 2.214, but it said it was all wrong.
And it said the upper bound was wrong for me.
Oh, really? Oh,
Yeah.
same. Just kidding. The answer in SPSS is slightly higher than in Excel, so the answer given is the average between the two results. Your result should be close to the answer shown. There's the answer shown.
Okay, so
If it's wrong, though, that's on the frickin' form, not us. Like,
let's determine the constant interval U1 minus U2 and estimate for the difference between U1 and U2.
We put it in right, correct?
Well,
Colorado variable 2,
yeah.
and it's not equal to the type of test. With any
Yep.
confidence.
I mean, obviously, yeah, so it should.
and it is a 95% interval, so let's just see.
I mean, we got the margin of error, right? So
Yeah, if the margin of error is right, then how can the intervals be wrong?
And the p-value and the t-statistic are all correct as well. Well, not t-statistic, actually. But the p-value is. Well, how can the t-statistic be wrong too, then?
did we do the... No, we did the right type of test. It said so. Yeah, I don't know. It didn't say to assume equal variances, right? No, it didn't. Oh.
We're positive it's a 2-sample t-test.
Yeah, I mean,
It wouldn't really make sense to do
the
really.
p-value wouldn't be right if it was a t-test. Because that's what's confusing is the p-value is right,
Yeah.
but the t isn't.
I mean, are we supposed to use the applet to get?
I don't
No,
think so.
every time it asks for the lower and upper bound, we've always just done it this way. It's always been right.
Yeah, it's always been
Well,
right.
that's what I thought, but I mean, what do you use the applet for?
The applet is for figuring out the t-score given the probability that something will like occur, right?
Okay. Okay, let's just save this.
So what I got from the applet is 0.843 instead of 0.845 for the t-score.
843.
Yeah, but that was already knowing the p-value, which I guess we already would have known. But that doesn't make sense that it would be, I don't know, that close. Well, it's also weird because all our other answers were right for the first question and the first set of things. Like our test statistic was right and things. So I'm not sure why it would give us the wrong answer for the second set of data if it didn't for the first set of data.
Yeah. Yeah, I don't know.
It doesn't make sense to me.
Sorry, I'm just trying to look up something. Okay. What did you get when you put it into the applet?
So if I put the respective p-value into the t-score applet, so if I put the p-value in for the area on the double-sided test or the two-tailed test, so on both sides, it gives me a t-score of 0.843 instead of a t-score of 0.845.
But that could be like, I don't even know, rounding error. Like that's such a small number.
I know, and that's why like Excel is designed not to round ever until the very end, and it only rounds to however many you set it.
You round around? What do we put? 845?
Yeah, 0.845.
Yeah, that's right. It's because it's 8447, so Excel
Yeah.
supposed to do.
Wait a second. Table. p-value that we put?
411.4.
Uh-huh. And if we do the 0.845 as a t-score, it gives us a 0.402, 0.4102 as the p-value. But the p-value was right, which would mean the t-score is wrong, which doesn't make sense.
Yeah, so.
And that might be what it was saying about the SPSS. If the that program is it. So for p-value or t-value or test statistic, it didn't say. It just said for the upper and lower bounds, they were slightly different. But I don't get that. It's weird.
So let me. The margin of error, right?
Yeah, our margin of error was right. So, like,
Doesn't make sense.
That even makes sense. Like, I don't even, like, so doesn't make sense that I don't even know how to fix it.
Yeah. So we just try emailing him. Or?
I'd be fine with it because I don't know that there's much that we can actually do. Like, if it's just showing us the wrong answers, I don't get it. Like,
Yeah.
I mean, even in this,
Okay,
as he's watching,
so-
when he watches the video or his TA or whatever, I'm sure he'll obviously see that we are having an issue.
12 and 10. Let's see here. Okay, I'm going to stop recording.